Good afternoon, everyone. My name is Allison Savage, and I'd like to welcome you to the Indoor Air Quality Science webinar series hosted by the US EPA's Indoor Environments Division. Today's webinar, Why Indoor Chemistry Matters, Findings from a National Academies Consensus Study, will be presented by Dr. David C. Dorman. Dr. Dorman is a professor of toxicology in the Department of Molecular Biomedical Sciences at North Carolina State University and served as the chair of the National Academies Committee on Emerging Science and Indoor Chemistry. Dr. Dorman's research interests include neurotoxicology, nasal toxicology, pharmacokinetics, and cognition and olfaction in animals. Dr. Dorman is an elected fellow of the Academy of Toxicological Sciences and a fellow of the American Association for the Advancement of Science. Dr. Dorman is a diplomat of the American Board of Veterinary Toxicology and the American Board of Toxicology. He's chaired or served on several National Research Council committees and is a National Associate of the National Academies of Sciences, Engineering, and Medicine. He completed a combined PhD in veterinary toxicology residency program at the University of Illinois at Urbana-Champaign, and holds a Doctor of Veterinary Medicine from Colorado State University. Welcome, David, and thanks for being with us today. So for the discussion portion of today's webinar, we'll also be joined by a panel of experts from the National Academies Committee on Emerging Science and Indoor Chemistry. I'd like to extend a warm welcome to John Abbott, chemistry professor at the University of Toronto, whose research activities lie broadly in the areas of atmospheric aerosol and multi-phase chemistry. William P. Vanbloth, professor of architectural engineering at Pennsylvania State University, whose primary expertise is in building, heating, ventilating, and air conditioning systems from the perspective of indoor air quality and energy efficiency. Ellison Carter, assistant professor in the Department of Civil and Environmental Engineering at Colorado State University, whose expertise is in indoor air quality, exposure science, and the residential built environment. Delphine Farmer, associate professor in the Department of Chemistry at Colorado State University, whose research focuses on outdoor atmospheric and indoor chemistry. Rima Haber, associate professor of environmental health and spatial sciences at the University of Southern California, whose expertise lies in environmental health, air pollution, and exposure sciences. Vicki H. Gracian, distinguished professor and chair of the Department of Chemistry and Biochemistry at the University of California, San Diego, whose research focuses on environmental interfaces as they relate to atmospheric aerosols, engineered and geochemical nanoparticles, and indoor surfaces. And Glenn Morrison, professor of environmental sciences and engineering at the University of North Carolina, Chapel Hill, whose research is related to the chemistry and physics of indoor air pollution and its influence on human exposure to contaminants. Thank you all for joining the discussion today. Before we get started, I'd like to remind everyone that this webinar is being recorded and will be made available on the EPA website at a later date. If you'd like to download a copy of the report we'll be discussing today, you can visit the National Academies Press webpage, and you can also find more information about indoor air quality, including the impact of certain chemicals on indoor air quality, on the EPA website, and we'll put those links in the chat box for you. Please note that today's presentation reflects the professional opinion of the speakers and does not necessarily represent the position or policy of the US EPA. If you have a question during today's presentation, you can type it in the Q&A panel on the right-hand side of your screen at any time. Questions will be posed to our panel for discussion at the end of the presentation. If you need any technical assistance, you can also submit those questions through the Q&A panel. And we look forward to hearing from you. So with that, David, thank you again for speaking today, and I'll hand it over to you.
Okay, Allison, thanks again. And welcome to everyone, and I'm glad everyone could join us for today's webinar. So it's been my honor to chair this committee, and I look forward to spending about the next 20 to 30 minutes just giving you a broad overview of this National Academies Consensus Report. Next slide, please. So as Allison mentioned, there's multiple ways in which you can get links to the report. The report is freely downloadable at the US National Academies website. And so you can use the link that's shown down below to be able to download a copy of the report at your leisure. Next slide, please. So the report is an overview of the state of the science on indoor air and indoor chemistry. But the stakeholders really, when we were developing the report, are actually fairly broad, and those include members of the public. All of us are occupants of different types of buildings, researchers that have an interest in indoor air quality and indoor chemistry, epidemiology, environmental health, and public health, practitioners across multiple domains, including practitioners in healthcare, housing, air quality, and individuals involved in construction and other types of aspects of building environment. We also have a nod to our governmental agencies that address public health, both at the federal and state levels. And then we also have discussed how communities can be impacted by indoor chemistry exposures and issues related to indoor chemistry. And then finally, policy analysts and legislators obviously are another target for our report. Next slide, please. So this report was sponsored by 4 different organizations, one of which is the United States Environmental Protection Agency, 2 other federal agencies, including the National Institutes of Environmental Health Sciences and the Centers for Disease Control and Prevention, also co-sponsored this report. National Academies also received sponsorship support from the Alfred P. Sloan Foundation as well. Next slide. For those of you that may or may not be familiar with the National Academies of Sciences, Engineering, and Medicine, that organization provides advice to the federal government. And indeed, it actually was created by Abraham Lincoln back in the 1860s for that express purpose. With all consensus reports, there's a statement of task that committees are asked to follow. And similar to us, we had a statement of task. And I'll briefly give you an overview of our statement of task. So our statement of task asked us as a committee to consider the state of the science regarding chemicals in indoor air. We were asked to specifically focus on new findings about previously underreported chemical species, chemical reactions and sources, as well as the distribution of chemicals in the indoor environment. We were also asked to see how findings related to indoor chemistry fit into the broader context of what is already known between linkages between chemical exposure, air quality, and human health. And before I move to the next slide, one of the things that our committee worked on was trying to understand what new findings would actually represent in the context of this consensus report. So new findings, for the most part in the report, cover science that's been developed over the past decade or so. You'll also find as you look through the report that there's some well-known chemicals that will appear in the report as well. And in those cases, we tried to focus in on new science that's evolved for those chemicals as well. One thing you'll also see is that we largely focused in on chemical species as opposed to biotoxins and others. And part of the reason for that is there's been recent other activities performed by the National Academies that covered that space. Next slide. So our statement of task actually continued to be pretty broad. We were asked to consider how the information that will be generated through the report might lead to findings and recommendations about implications of the scientific research and where there could be near-term opportunities for incorporating this science into practice. We also were asked to look for where additional research in chemistry would be most critical for improving our understanding of the chemical composition of indoor air and the potential for adverse exposures. We were asked to look at how advancing such research might be affected by technological barriers or how collaborations or coordinations may actually improve that space. And then finally, the committee was also asked to provide recommendations for how to communicate its findings to affected stakeholders. And this webinar is just one aspect in this communication outreach that Academies is performing. You'll see that the last sentence talks about the fact that indoor environments that were focused in on this study were limited to non-industrial exposures within buildings. So residential buildings, schools, hospitals, and other non-industrial exposures were considered by our committee. Next slide, please. So our committee had broad representation from both academia, governmental agencies, and NGOs. The scientists that I was honored to work with have a broad range of expertise, some of which has already been described by Allison, but we had people with backgrounds in environmental health, chemistry, engineering, toxicology, building design, and other scientific disciplines. We were also assisted by Dr. Megan Harries, who's a member of the National Academy staff. Next slide. So this report was released about 4 weeks ago now. And what I'll be trying to do in the next 20 or so minutes is just provide you an overview of both the report structure and the main messages that our committee came up with. Next slide, please. So the report has been structured into 7 standalone chapters. There's a short introductory chapter that will introduce the topic of indoor chemistry to the reader. And then what the committee did was we parsed out this scientific space into various different domains. So we talked about primary sources and reservoirs of chemicals indoors in chapter 2. We discussed partitioning of chemicals in the indoor environment in chapter 3. Chemical transformations, in which different products and reactions occur, is the subject of chapter 4. In chapter 5, we discuss basically mitigation strategies and how management of chemicals in the indoor environment can occur. In chapter 6, we discuss the linkage between indoor chemistry and exposure. And finally, in chapter 7, we look at cross-cutting issues and have defined a path forward for research to improve our understanding of indoor chemistry. Each chapter provides an overview of the current state of the science and research needs. And because of the time allowed to me today, I'll be focusing most of my attention on chapters 5 and 7 and just give you a hint of what you'll find within the report. Next slide, please. So what are some of our main messages? So one of the really important messages is that most of us spend most of our day-to-day existence in a built environment. We spend a lot of our time indoors. And that depending upon how the building is used, we can have different environmental conditions, and the environmental conditions in indoor chemistry can vary tremendously from building to building. So for example, the indoor chemistry found within your home may be different than that found within a hospital or a school or a cafeteria. Next slide, please. What's also important is that although we've got growing knowledge about indoor chemistry and its impact on the indoor environment, we still know very little about how humans are exposed to these indoor chemicals across different pathways and across different exposure routes. So exposure routes in our case can include things like inhalation of a chemical, where we're breathing the chemical in from the air, or we may come into contact when we touch surfaces and actually touch chemicals found on surfaces, where we can have dermal exposure. Or in the case of both adults and children, we'll sometimes ingest chemicals in our home environment. We don't always understand how these exposures occur over different timescales. And unfortunately, we don't always know what the cumulative or long-term impacts of these exposures might have on human health. Next slide. What we also recognize is that the outdoor environment is undergoing dramatic changes due to things like climate change, increasing urbanization, and wildfires. And these changes in the outdoor environment can have significant impacts on the indoor environment as well. Fortunately, over the past decade, there's been a number of new analytical tools that have been developed, and these have played an instrumental role in understanding and improving our understanding of indoor chemistry. Although there are still the need for significant strategic investments in this domain to allow us to have even better tools to better understand indoor chemistry. Next slide. So this knowledge really can't just sit in a vacuum. We need to be able to take our knowledge of indoor chemistry and really translate it into practice and policy. We also find that there's a large number of chemicals within the indoor environment. So for example, there's estimates of anywhere from hundreds to even thousands of chemicals that might be detected within an indoor environment. And for many of those chemicals, there's little or no information regarding their toxicity, either as an individual chemical or as they may occur within the environment, in which combinations and exposure to multiple chemicals can occur simultaneously. We also recognize that mitigating chemical hazards in the indoor environment may require us to change building design and operations. We may have to alter the use and contents of different products and materials in the built environment. We also have to consider the important impact of human activity itself on indoor chemistry. So for example, cooking in the indoor environment can oftentimes change the indoor chemistry. Next slide. So in chapter 5, we discuss indoor management and removal of contaminants. And so I'll spend just a few moments trying to talk about that. So next slide. So when we think about managing the chemicals found in the indoor environment, there's two broad approaches that we could consider. One approach requires us to capture or remove the chemical. And so these capture removal techniques can include things like mechanical or natural ventilation. We could filter out different particles and chemicals. Chemicals may desorb onto different surfaces, or we may even do physical cleaning of surfaces. And increasingly, we're seeing engineered surfaces that are designed to actually capture and remove certain types of chemicals in the indoor environment. But in addition to that, we could also alter the chemistry in the indoor environment. So for example, we might add chemicals to actually change the fate of other chemicals indoors. So for example, we might add a scented product or a disinfectant or hydroxyl radicals or even compounds like ozone. In the case of biological materials, so for example, ultraviolet light has been used to control things like bacterial infections within hospitals. And so that chemistry from ultraviolet light can also play an important role. We discuss ionizing devices and photocatalysis within the report as well. But each of these different approaches can alter the chemistry as well. Next slide. So each of these methods, be it either filtration or chemistry, have different consequences. And so no single management approach is going to be able to remove all of the chemical contaminants that are found present indoors. And so it's important for us to understand those consequences. So if one was to say do additive chemistry within the indoor environment, how does that change the chemistry? And does that provide avenues of exposure that might be detrimental to human health? For some of these techniques, they've not been looked at extensively in real-world environments. They may have been studied in a laboratory situation, or the amount of knowledge we have of different types of techniques might actually be quite limited. Next slide, please. So for different types of air cleaning technologies, our fundamental understanding of their chemistry is a knowledge gap that needs to be addressed. And we need to consider both the efficacy, how efficient does these things work, as well as their safety. And so different testing approaches may need to be developed in the future that consider both efficacy, chemistry, and safety in a representative range of real-world environments. So again, how do these different air cleaning technologies, say, work in an actual school or a hospital or a home? Next slide. So in general, the committee cautions against using approaches that could cause changes in chemistry in the occupied setting. So when we're looking at, say, chemical additives, we need to consider, do the benefits of those chemical additives outweigh the potential risks of exposure to different chemical reactants and byproducts? And in all cases, elimination of sources is always the preferred method of control. Next slide. So we also need to understand how partitioning within the environment could impact air cleaning technologies. And for those of you that may not be familiar with the concept of partitioning, a chemical that's found in the air, for example, can eventually partition to, say, a surface. So within your home or another type of environment, we have a variety of different places in which chemicals can actually move and be dispersed within that indoor environment. They might end up partitioning onto glass, for example, or fabrics that are found within the home. And then those compounds that are found on glass or on a fabric can actually come back into the air again. And so chemicals can move back and forth between these different phases. And so we need to understand how that partitioning of chemicals might impact air cleaning technologies. Because in some ways, air technologies may be only cleaning the air for short periods of time, and then partitioning allows chemical buildup to occur again. So we need to have controlled field experiments to better understand this chemistry of the emerging air cleaning technologies. And it's going to require some collaboration between both device manufacturers, public health professionals, and researchers to try to communicate clearly to the public about the efficacy and potential beneficial and adverse chemical consequences of different air cleaning approaches. Next slide, please. So if you go to the report, you'll obviously be able to find much more information about mitigation. And what I want to do now is just transition briefly to a brief discussion of Chapter 7, because in Chapter 7, the committee lays out a path forward. And what we tried to do is look at different cross-cutting topics, and our recommendations found in Chapter 7 really center on 4 of these topics. So as I mentioned before, the complexity of chemicals in the indoor environment plays a major role. And so we discussed different recommendations related to that. As I also mentioned, we have a changing world, increasing urbanization, wildfires, climate change. So how will indoor chemistry be impacted is also discussed in Chapter 7. We do give some advice to different policymakers about the need for future investment in research. And then finally, we talk about the need for communicating science and risks to the public and other stakeholders. Next slide, please. So one of the things that we feel is a critically thing that we need to do is to try to actively engage different stakeholders. And as I mentioned, our report tries to target different stakeholders, from people living in built environments to scientists to regulators and others. And that researchers should try to proactively engage in these linkages that can connect our research to application throughout the indoor chemistry research process. So for example, writing a scientific article, which many of us do, in and of itself can be very valuable, but at different stages, we may need to engage with technical and standard writing committees at conferences and other types of venues to try to disseminate our research findings more broadly. And then see our research findings actually lead to impacts in which indoor chemistry might be improved. Next slide. What we also understand is that there's going to be increasing use of different types of devices indoors. So for example, sensor devices will be increasingly used indoors. Different consumer products are going to be developed, and different consumer services are going to be provided. And so one of the things that we felt is important is that we have to have a better handle on how different products that are known to change indoor chemistry. So for example, air cleaners that rely on the emission of an oxidant, or disinfection systems that rely on ultraviolet light, we need to understand the impacts of these types of things on indoor chemistry. And not just indoor chemistry by itself, but also the linkage to human behavior. We need more investments in interdisciplinary research, and we need to look at how these different products and services not only change indoor chemistry, especially under realistic conditions, but we also need to understand how information that might become available to an occupant may lead to behaviors that can positively or negatively influence indoor chemistry. Next slide, please. There's a need for test methods to allow for certification of air cleaning products and services. One of the concerns the committee has is that some of these products are sold to the public without really a good knowledge base as far as how safe or effective they actually are. And so if we're trying to have different types of services and remediation techniques that have an uncertain value and that may actually impact both indoor environmental quality and adversely affect occupant health, we need to protect the public from that. So in the future, there may be need for developing more standardized test methods for that purpose. Next slide. So obviously, this is a really brief summary of a several hundred-page report. And the report, as I mentioned before, provides a brief summary of the state of the science in indoor chemistry. And we're hoping that the roadmap for the research agenda that we presented in the report will help advance this highly disciplinary field of indoor chemistry. And with that, I'll bring this to a close, and I'll invite all of my co-members of the panel and committee to join us and try to answer questions that you, the public, might have regarding this report. Thanks.
Thank you so much, David. And yes, members of the panel, feel free to turn on your cameras, and I'll have a few questions here from the audience. A reminder for the audience, you can continue to submit questions through the Q&A box on the right-hand side of your screen as we go along through the discussion. So our first question today is, what are some of the most important public health actions that you can take to reduce indoor exposure to chemicals and chemical byproducts?
So I'll take a quick stab at that, and then I'll, as my fellow committee members, they can add in. There are some simple things people can do. So for example, as I discussed, there's sensor technologies out there. So unfortunately here in the United States, for example, we still see deaths associated with things like carbon monoxide poisoning. So having a home sensor that detects carbon monoxide could be a simple solution for that problem. Other types of things you might consider doing will be things as simple as just using ventilation that's already available within your home, like turning on different types of exhaust fans when you're cooking. But I'll allow others to jump in with other advice.
Oh, sure. Bill Bonfleff, I'll say a couple of additional words. I think Dave is on point with the idea that we need to measure more things indoors so we know what's there. We have thermostats for temperature, and we've gotten used to measuring humidity. I think that as we become aware of what the key indoor contaminants are, knowing what their levels are and that we're doing enough to control them to appropriate levels is going to become the norm. And I think for homeowners, maintaining indoor air quality is maybe harder than for commercial buildings that are designed with ventilation systems, because you have to develop habits of having good indoor air quality. I have a house that has no mechanical ventilation, so I have had to just develop the habit of opening windows when I can, when the outdoor air quality is good, and it makes a big difference. And the IAQ here is I can measure with various devices. I can check CO2, I can check particulate levels indoors, and it really makes a difference.
I would maybe just add to that, reading product labels, especially cleaning products, and knowing what chemicals you're maybe introducing into your home that you could find safer substitutes for. There's a lot of kind of educational material these days online to try to think about the products you use every day in your life, personal care products and cleaning products.
Oh, source control is really important. When we bought our house, the entire house was carpeted. Discovered there were hardwood floors underneath all the carpeting. All the carpeting is gone, and again, that makes a noticeable difference even from the point of view of odors. You have a choice to have an electric range or a gas range. So there are many things you can do that are easy that will help.
I'd maybe like to follow up on that as the contrast to when you own and occupy your home and have the agency to make changes. I think the changes can often be made at an individual home level, and something I think we tried to address in the report, although there's a relative deficit of information on housing that's occupied by people that maybe don't have as much control over that environment. And so it may be in response to the question about public health actions, I think engagement with housing authorities, engaging with rental property management, which has historically been very difficult. This isn't something we have a long history of having success doing, but I think those would be also some public health actions that might then influence the indoor environments where people living in them maybe can't make as many changes.
Right, and those health disparities and knowledge about that's extremely critical, and our report does delve into that issue.
Definitely, I think that's definitely something that's important to consider. And we have kind of a related question here about public spaces. And since a lot is not known about the synergistic effects of using multiple products in a home or in a business, what can be done to protect the public, especially sensitive populations like asthmatics, from everyday chemicals like air fresheners in public spaces?
I mean, with COVID, people have started to use these very cheap CO2 monitors that give an indication of how how well ventilated a highly populated space is. And so, you know, they can be used to tell you whether or not the ventilation is working well, and the risks are minimized versus if the ventilation system is not working well.
I think in public, of course, displaying metrics of air quality is, I think, helpful too. I mean, the public would like to know, but if the owner knows that the public knows, then that may affect people's choices about whether they want to be in a particular building or not. So I think disclosure going forward could be an important tool.
Yeah, and I'll add that there's a lot of opportunity for that in public buildings, where, you know, libraries or school systems. There's an opportunity to start thinking about metrics for indoor air quality too, not just residences.
Yeah, and I just want to add that it was already stated, but we already do have measurements going on indoors, whether it's temperature. In museums, there's always relative humidity being controlled and managed and reported out. You might see some instruments in different rooms within a museum. And so if we continue to increase this level of monitoring and displaying, as everyone has just discussed, I think that's really the way we want to go, so you better understand the indoor environment that you're in. Again, with CO2 levels, if you see them going very high, if you're feeling that this is not a good space for you to be in because of that limited ventilation, then you can remove yourself from that space by knowing those numbers. So I think disclosure is a lot of what we discussed during our committee meetings, and we actually and put in our report as well. So I think that's really a step forward for the public and for everyone, is these getting that information and being able to make choices based on that information.
And Allison, I think one other thing the report touches in on is the need for knowledge about the hazards we're dealing with. And I'll point to things like just secondhand tobacco smoke over the years, where different communities have banned cigarette smoking, for example, in restaurants and other public spaces. And that was driven largely by an increased amount of knowledge about the adverse effects of that compound, for example. So I think, you know, really having that information can help guide policymakers in their decision-making in public spaces.
Definitely. I think that leads into another question that we received. You know, how important will it be to look at the impacts of certain VOCs indoors, and what types or sources of VOCs should we pay special attention to?
Yeah, I can start with this one. It's a really interesting question, because over the last 5 to 10 years, we've really learned that there's a huge number of volatile organic compounds, so those VOCs in the air, but and a lot of them, you know, so quite a few of them we know are in outdoor air as well. So there's a molecule called limonene, which is what you get what you smell when you cut open a lemon or a lime. You're smelling that, or a citrus scented product. It's also present in outdoor environments quite naturally, but that's an interesting product, because I think there isn't any evidence that that molecule is dangerous in and of itself. But if you do chemistry on it, you can turn it into things like formaldehyde, which are more toxic. However, what we don't understand, and I think this report highlights really nicely, is that is exactly what levels we should be concerned about from these myriad compounds. So we understand formaldehyde, I think, reasonably well in its toxicity, but there are other VOCs that we don't understand necessarily quite when they're going to be toxic, especially in the complex mixtures present indoors. So I think I think VOCs are a really interesting class, because they include a lot of non-toxic compounds and a few things that are known to be toxic, but those levels in the indoor system is a bit complicated.
Just following up on that, the release of molecules that we know will be converted into something else indoors is by itself sort of problematic, because we know what's going into a particular product. But once it's in a building, then it gets converted into maybe 100 other things that we lose our information about what's there unless we actually do the study. So reactive molecules are something probably to avoid.
I would maybe just add to that. I think in the report, we also highlight how dynamic the indoor environment is and how all these reactions could happen very quickly or very slowly in some cases. And just the need for us to really kind of do more mixtures, modeling, and understanding of how we as humans are exposed to mixtures of these compounds. And we need to also understand how they affect our health together rather than in isolation. And that's where a lot of the sort of instrumentation and untargeted methods are really helping us fill in these knowledge gaps.
And just to go on a little bit more, feeding off of what David talked about earlier with respect to partitioning, and there's a phenomenon called third-hand smoke, where after there's smoking indoors, many of the molecules partition between the gas phase and the surfaces, and so and they can reside on the surfaces for a long time, so that you can think that you have ventilated the whole space and the smoker's long gone, but then you go back into that room and you still smell the smoke. And so what you're smelling are the VOCs that are coming off that surface. And so those VOCs can you can carry them around on your clothes. They can exist on upholstery or carpeting for a long time and be getting chemically transformed. So it's a very complex set of processes that are going on and can extend for quite a long time as well.
And Delphine touched on an important point, though. There's so many things that could have chemistry, but to go back to sensors, how many sensors can we afford practically to put into a building and keep calibrated? So science really needs to help us get down to the ones that are likely to be there and be harmful most of the time. Otherwise, we're going to have a system that can't be practically implemented for control.
Actually, that
And
leads
Allison,
quite well. Yep, go ahead.
just
Sorry, go
one
ahead.
other quick thing too for the people participating and listening to us. Going back to how could I control VOCs in, say, an environment, one of the simple things to do is try to limit introduction of these chemicals into your environment. And so, being a conscious and a consumer of different products and understand you may be buying a scented product, but it may be containing a wide variety of different chemicals that may be less desirable. And so making those choices of deciding not to bring something into your home can actually decrease the amount of chemistry that might be occurring as well.
I think that all leads very nicely into another question that was submitted. Are there kind of certain products or certain ingredients in products that are, of concern that you might want to avoid? I know we've mentioned like limonene, or we've talked a little bit about third-hand smoke and that sort of thing. And also, are there kind of priority chemicals that you'd want to measure in an indoor space?
I think I would say I would answer the last question first. In terms of priority chemicals, right now we know that certain things are really toxic, and so if we think about what we know and what's very well established in the literature, you can look at compounds like formaldehyde. You can look at components like particulate matter. Those are well established in the literature to cause negative health effects. So I think it's quite clear that the first things you would want to go after measuring in your homes are things that we already know are dangerous and that you want to reduce. And there are some some of those you can measure quite easily, like particulate matter. There are lots of cheap indoor sensors that you can use. Things like CO2 in and of itself, we're not as worried about as long as the concentrations are lower, but it's a useful indicator for some of the other chemicals that you're thinking about, as John Abbott mentioned earlier. But I think in terms of some of these other questions about which molecules should you be most concerned about, I think that's a really difficult question to answer, because if you look at the back of something as simple as a shampoo bottle, you'll see a huge number of compounds. Many of them, unless you have a chemistry PhD, are unpronounceable. Right. And so that makes it quite difficult to give a list of a handful of compounds. And I think that's somewhere where this report really points to the need to start figuring out exactly which compounds one should be most worried about and which ones we should be thinking about for public health.
And I would say, I was actually going to,
Go ahead.
Allison, I was going to suggest that you chime in here.
Okay. Well, since you're on the same page, I think what I wanted to build off of what Delphine was sharing is that in addition to the harm that a compound may or may not have. There's also a value in looking at how it's used. And I think that's one of the reasons the chapter on indoor chemistry and how it relates to exposure is an important chapter in the report, in that if you use a shampoo once a day versus some other product that you use once a month, or you use shampoo for 30 seconds and you have the chemicals in the air maybe for an hour in a bathroom where you might spend less than that hour of time, your exposure might be quite low to certain compounds that we really only have data on for, or no data on, but for chronic exposure. So when we think about what to prioritize, it also really is important to consider that in light of time activity patterns and use patterns. And on that front, we have actually pretty limited information. And I think one of the things that we call out in the report is that in addition to understanding indoor chemistry better, understanding how things get used in these indoor environments is really critical to understanding a priority in one context might not be in another. I don't know if that's what you intended, Glenn, but that's where I was headed.
Partially, but yeah, and in addition to that, I think what you and Delphine are sort of pointing out is that it's very difficult as an individual consumer to make these choices and make these decisions, except for the most toxic of molecules, which probably aren't in most products, right, at levels that are, really toxic. We can't really make really good decisions as an individual, but we can make decisions as a society based on time activity patterns and based on toxicology, based on animal research or whatever, to say, these are the kinds of things that are problematic and we should not have these in our products to begin with. And that's probably where we get the biggest bang for our buck, as opposed to making decisions on the individual level.
And I think indoor combustion is the other thing I'd mention. Just trying not to have combustion processes indoors removes a whole host of harmful things. I can't think of anything good that they put into the air.
And
Yeah,
I think there's also concerns about certain consumer products, like some cleaning agents, for example, like bleach or ammonia. Those need to be used judiciously, and you might question whether or not you actually need to use them. Indoor use of pesticides, for example. So there's a number of other types of chemicals that the consumers can think about and really try to understand whether or not it's needed for that application in an indoor environment. Sorry, Delphine.
No, actually, that's great, because I want to build off of that point about cleaning, that we often think about the primary product, the actual ingredient in a product. But one thing that I think the report highlights really nicely, and we spent a lot of time discussing, is that you can start with one product that's initially benign, but you can oxidize it or change it and turn it into something that is not benign, something that's dangerous. And that's where as a consumer, you can really think about reducing that opportunity for that secondary chemistry to occur. And so that's when you look for products that release ozone or release other oxidants, and as well as cleaning products that are oxidizers like hydrogen peroxide or hypochlorous acid, so bleach. So those sorts of compounds will actually turn some of your otherwise benign chemicals into something that's more toxic. So I think that's another thing that the consumer really can do, is to pay attention to not bring oxidants into an indoor space unless it's really essential.
Could I add one more comment to this discussion? I think it's and it sort of links back to David, how you opened, that although the charge is very focused on indoor chemistry, this topic can touch a lot of stakeholders. And I think in the report in multiple places, we try to highlight that if you're optimizing for reducing exposure, you might make one set of choices, but the choices about what we bring into our home and how we use them is a function of many other factors, including cultural ones, social ones, personal preference, taste, aesthetics, things that are really vital to our well-being and health in other ways, or may be. And so I think although the report stays true to its charge and focuses on the indoor chemistry, and the response to this question reflects that focus, I think we also acknowledge in the report the more complex system within which these decisions are made.
And I'm just going to add on to one more thing, and that is, and it has been stated a few times already, and that is how we don't understand the life cycle of a chemical indoors. And I'll just sort of put it that way. So you have an emission, a source, and then you have several different processes going on. People have already talked to them. We have transformations, things, molecules will stick to surfaces, and it's these processes that we talk about in the report as being really understudied, under our knowledge lacking in many cases, and that is something that's a consumer is not going to be able to really figure out. So part of our report did discuss this need to really take on this problem of, understanding the life cycle of different types of molecules, VOCs, other types of molecules indoors. And that's really a big chunk of that report, if you will. Chapters 3, chapters 4, I believe, really go into some of those details, as well as chapter 5. So how things evolve over time, and we discussed timescales, is really something that we feel as a committee is really unknown, understudied in many ways, and we're just figuring out some of these different processes. So I just wanted to, repeat some of the things we said already, but really that whole life cycle of a chemical indoors is something we really want to get at and better understand.
Definitely. One of the things we've been getting a lot of questions in the chat box about is different types of air disinfection technologies. And I know in the report states that you caution against approaches that induce secondary chemistry in occupied settings unless the benefits demonstrably outweigh the risks of exposure to chemical reactants and byproducts. Some of the types of technology that have been mentioned are like UV lights, dry hydrogen peroxide. I think bipolar ionization came up as well in schools and that sort of thing. Are there any priority actions or specific advice for consumers that you would recommend, or sources of information that they might go to help them understand those technologies?
Well, I could say a few things about it. It's been very difficult for the last 2 years to make really unqualified recommendations to anyone about disinfection technologies, because there's a big gap in terms of reliable application, relevant methods of test for the various technologies that have been put into the marketplace, both with respect to efficacy and also with respect to safety. This doesn't mean that the products in the market aren't effective and safe, but it's really difficult to demonstrate that from most of the data that's been put out by the manufacturers. And so there are efforts underway to develop better tests now, and talk of looking at byproducts as well as the effectiveness. But the availability of those and certification programs are some ways off. So to sum it up, organizations that have had to weigh in on this as to what do we really know is effective and as far as we know safe, the air cleaning technologies are pretty much down to things that remove particles from the air, and probably ultraviolet disinfection as well as the conventional ultraviolet disinfection using 254 nanometer UVC. I've seen plenty of data that other technologies work as well, but still have reservations about whether we understand them well enough to recommend them on the same level that we do the 3 technologies that are commonly used: ventilation, mechanical filtration, and UV disinfection.
I think I would add to that and say that, I mean, as Bill just mentioned, there are those methods that are really, really well understood to work, and as highlighted in our report, but also elsewhere in the literature, have really no downsides. And I think I would point to filtration in particular as one of those, and usually mechanical ventilation, unless there's an extreme air pollution event outside. And but in general, those techniques are so well established. And then a lot of the sort of germicidal UV there's a lot of potential there. But that one's a little trickier because there are also different wavelengths of ultraviolet light, and some of them can produce ozone. So I think really watching, and I think the EPA actually has on their website notes about some of those air cleaners in terms of things to watch for. And to a consumer, one theme that really came out of this report is the importance of reducing secondary chemistry in the indoor environment, because there's so much reactive material both on surfaces but also in the air. And so choosing air cleaners that don't induce that secondary chemistry. So again, that filtration, that ventilation, and that germicidal UV, those are mechanisms that should really, I think, be chosen over the unproven or less well understood other technologies that are out there.
And I think to some extent, one technology may help mitigate the shortcomings of another. Sure, but we can bring in lots of outdoor air to dilute indoor sources. But if we're in a place that has high ozone and high ambient PM, we are creating a problem there that we can really only solve by adding other technologies to clean it up or to substitute for them. So we have to consider this holistically, and a lot of that is discussed in the report. The problem that we may be solving one problem and then creating another with lots of ventilation in urban areas.
Yeah, I was just going to bring up that point, is that it's very easy to say ventilation is a good thing, and it does ventilate chemicals that are sourced indoors and takes them outside. But if you are living in a very polluted environment, then we know that breathing particles is bad for us, and there are more particles generally outside than inside in the absence of a combustion event, for example, like cooking indoors. And so it's not a simple assessment on in terms of health effects. And so if you're in a wildfire and it's poor air quality outside, it probably is a good idea to close your windows and not ventilate. But if you're cooking and you're in a beautiful, pristine environment, then it's a very good idea to open your windows and get rid of those cooking emissions.
Definitely a great point. You actually anticipated my next question about when there's poor outdoor air quality with ventilation. So thank you for that. Another question we received, or a couple questions we received, was how could green building or sustainability renovations impact the exposure to chemicals indoors? And kind of on a related note, how can we get builders to jump on the bandwagon, so to speak, to start including some of the solutions that you've talked about in new building construction?
Oh, you're very much getting into the realm of a carrot or a stick. You'd like to think that if you just showed that something worked and then would have a benefit that would pay for itself, that everyone would do it. But the history demonstrates that most construction gravitates to whatever the building code will allow. So an important tool here is to get these technologies, to the extent that's possible, into the building codes, because that's how most buildings are going to turn out. I think there's a lot of good advice and guidance in green building standards and wellness standards, but the percentage of buildings that are following those is pretty small. In the big picture, it doesn't really address existing buildings. So we need to think more broadly about how to influence all the buildings that have already been built and that have problems built into them that need to be remediated. So it starts to get into the realm of policy and standards. And of course, we've discussed that in the report as well. How arduous a process it is to go from well done science to a regulation that someone actually has to follow. It's years.
Definitely.
Oops, sorry, Allison, just to quickly add to that point, I think we also talked about, it's important, let's say, to have low emission products or other products that are used in building design, and the science is getting there and the recommendations, but also we still have a hard time knowing exactly what chemicals are in certain products. There's a lot of proprietary information out there. And so just in terms of advancing the science, it's very important for us, to be able to have access to that information and have the reporting of, chemicals used in these various products be known to us so that we can develop those databases and look at those risks and really understand them. So some of it is a bit cyclical, kind of like what we're all saying. Thanks.
And Allison, I think the other thing the report points to is the need for kind of partnerships between different groups. So for example, scientists and in partnership with policy setters and manufacturers of different types of goods. So I think that again kind of leads to this being a multidisciplinary problem. And as Ellison also mentioned, that's also an issue that's very different between communities that can afford to take action versus those that have got less resources. So that's a whole nother issue that needs to be considered, largely by the policy folks, is how do you assist, different groups with health disparities already, and what can we do to try to improve their indoor chemistry?
I might want to add on to that, David, and Bill, I hope you'll jump in and correct me if I'm wrong about this. I think you mentioned, the fact that existing housing stock, significantly overwhelms new housing that's being constructed, or even, if we're not just talking residential, non-residential spaces. And so there's already a lot of existing indoor space that could have the potential for retrofitting, and that's certainly a hard, it's not an easy process, but there is some past precedence with the weatherization programs, being focused in the United States since the 70s on energy efficiency, but multiple white papers and now research groups and I would say a diverse array of publications, not just scholarly literature, that is making a case for energy plus health, and trying to leverage the opportunity when you're at the physical home, making a change to include or incorporate changes that also address indoor air quality, that may also address downstream health effects. It's not a perfect science, and I think all parties involved, as David said, it's a multidisciplinary effort. So there's some compromise, like we may not get the best indoor air quality if we're also trying to get energy efficiency. It doesn't mean that they have to come at a cost for one another, but there needs to be some willingness to optimize for multiple outcomes. But I think the trend I wanted to point to is that I have observed an increase in valuing multiple good outcomes at the point where you get to make a change to a physical space like a home or a workplace. But Bill, I really look to you and maybe others as an expert. So if I've mischaracterized, I hope you'll jump in.
I don't think I have anything to add to that. That was a good comment.
I will follow up on that just to ask a question about, I know the report talks quite a bit about kind of environmental justice issues, and you spoke a little bit about, weatherization and changes to buildings and things. Could you speak a little bit more about maybe what some of the disproportionate impacts might be for these communities, or some of the resources that might be available? For example, if there's government agencies or anything that the report might have identified, programs that might be able to, be part of the solution for some of the disparities that we have identified with those communities.
So I'll take the second half first. That was actually beyond our scope. And so the report really does not identify those resources. And so folks here on the committee, if we talk about it, that'll be just have folks realize that that's outside the scope of the actual report. As far as the health disparities, though, I mean, it is critical for us to understand that. I mean, occupancy rates can be different. The use of different personal care products can be different. I mean, there's just so many ways in which these types of disparities kind of compound on each other. And I think that's one of the things that COVID revealed is that, the most affected communities are oftentimes, the ones that have got these types of disparities that are present.
And I would just add, I think Ellison kind of already made great points around the health disparities and sort of, certain groups having more or less control over their environments and their immediate kind of individual space versus the community level In the report, we actually go into a lot of detail about different exposure determinants in a health disparities context, and we acknowledge or kind of report around the fact that certain communities are disproportionately exposed to very high levels of certain kinds of exposures and chemicals in the outdoor environment in close proximity to their homes, but also through various housing conditions, perhaps under different, climate scenarios, etc. And it's important to recognize that susceptibility or vulnerability to those exposures can also be different depending on these coexisting conditions. And so, again, as David said, part of it is beyond the scope of actually giving recommendations, but we do discuss in detail. I don't know, Alison, if you want to add anything to this, the kind of the health disparities context and the issues around those exposures and risks.
And
Yeah,
Allison,
Rima, I think you, yeah, go ahead, sorry.
sorry, I also wanted to bring up another population. There's other sensitive subpopulations, like children, for example, whose exposures in a built environment can be quite different than, say, in adults. And so, this understanding doesn't, I think we need to also be aware of those differences as well.
Yeah, and
Allison, go ahead.
Go ahead. Yes,
I think
Allison.
the point I had wanted to maybe make, I'm recalling some of the pieces that we built into the chapter on indoor chemistry and exposure, is that although we do go into depth on a number of determinants of exposure, and there's a literature from which we can draw from for that, those determinants are upstream of the actual exposure, and so they might be indicative of the potential for exposure disparities in indoor environments, but the reality is we have very little data in indoor spaces relative to the amount of data we have, say, in outdoor air to assess disparities in exposure. And so when we talk about the potential for disparities in exposure in that chapter, it's really also to highlight the limitations of having a much sparser and more heterogeneous data set. And I think that it linked back, at least my memory is that it links back to the call for measurement science to improve, because one of the reasons we have such less data indoors than we have outdoors is that the deployment of sensors or devices or sampling technology is just significantly more curtailed. And there are advances that are highlighted in the report that are happening, but we're certainly not on the tapering side of the S curve in that space. So I don't know if others would want to add to that, but I think that's one element of the disparities, that we have indicators that they might that we would expect them, but they may also be counterintuitive. There might be some disparities where poorer, more disadvantaged communities might actually have lower exposures to some things and higher exposures to others. And that's not to take the emphasis off wanting to learn about those, but that we may find some counterintuitive findings if we collect more measurements in different contexts with different subpopulations.
To follow up on that, Allison, I think that I believe that we probably will find those kinds of differences. I'm not sure if you call those disparities, but definitely differences in exposure, and that specifically, that's why we should be looking at this, right? So we can identify them. Yep.
It certainly suggests a way of thinking. We have to identify what is in a particular environment that causes the most harm and what is the most economical way to deal with it. And of course, there are a lot of things that you can do, as we've discussed before, that simply getting things out that are sources is maybe the place to start if those can be identified. Is the more expensive solutions often have to do with technologies that aren't economically accessible to everyone.
As just one example, if in most surveys, people at the lower end of the economic scale actually tend to keep windows open more. And part of this has to do with the types of buildings they tend to live in, but this means that they probably have higher ventilation rates and more exposure to outdoor air pollutants, but therefore less exposure to indoor air pollutants on average. But it gets a lot more complicated than that because of all the other things that Allison's brought up, things like cultural differences and things like that that can influence exposure.
So switching gears just a little bit, we had a question about kind of the balance between air ventilation and energy conservation. It seems the more ventilation we employ, the more climate control systems would need to work to maintain a desired temperature. Could you speak a bit to kind of if there's a trade-off there between ventilating for, you know, removing chemical contaminants and that climate control issue?
I mean, a trade-off with energy?
Yeah, with energy,
Yeah.
with costs.
Yeah, well, you know, obviously, the larger a system is, the more it costs to build it, and fan power goes up. But the big thing is conditioning outdoor air to bring the temperature down to the indoor temperature and to control humidity. But on the energy standard side, we've got a long history of asking for ever higher energy recovery efficiencies. You know, so we now have equipment available that can recover 80% or more of the energy impact of bringing in outdoor air. So even with ventilation and passive house designs, that sort of thing, we can do pretty well. But the paradigm of the future, I think, is to not depend on ventilation for everything, and ask whether there isn't a better way that uses less energy to deal with a certain contaminant. And also, again, back to sensors, demand control. Now, we think of demand control in most building designs as a way of making sure nobody gets any more ventilation than they're entitled to. So we turn down the ventilation to save energy. But if we were doing demand control that was based on where people are and what they're exposed to, I firmly believe we could deliver better indoor air quality where the occupants actually are and still save a lot of energy in buildings. We know that from the pandemic. Buildings were practically unoccupied in urban areas like Midtown Manhattan financial district, and they were still using 90% of the energy that they used when they were fully occupied. So that means we could design those systems a lot better.
Excellent. So you mentioned sensors, and we did have a question about that we frequently hear about sensors or home measurement equipment that uses TVOC or total VOC concentrations, but there doesn't seem to be a consensus of what's meant by that term. Does the report mention this or have any suggestions to help those of us who are using sensors or designing them to make this information a little easier to convey or understand?
I can start with that one. I think total VOC is really hard it's a hard term to think about, and it's a really hard thing to measure. So I think it's hard to think about in the indoor environment because so many VOCs are actually not harmful. And if you have one of those sensors and you will cut open a lemon, you will see that TVOC, if it's working well, should go up very, very much. But that doesn't mean that that's a bad thing to do. And so I think TVOC as a number can be, people can use it as an indicator, much like they use CO2 for how much stuff is in the air and whether, how effective ventilation is. But it's a very, very hard concept to measure because organic compounds, the volatile organic compounds that you're trying to measure, are structurally so different. All these different molecules have very, very different shapes, very different components on them, and therefore very, very different properties. So it's an exceedingly challenging task to actually build a TVOC sensor. I think it's one that's plagued atmospheric chemists for a couple of decades now. And so those sensors in indoor environments are unlikely to be measuring exactly what you or the manufacturers think they are measuring. And so I think there's a call to think about what that number means, but I think we would probably all urge consumers to use that with caution and think about it in terms of, are you cooking a lot of things, and is there a lot of stuff in the air that you are currently breathing? And if so, that's a great indication to turn on fans or to think about other things that you can do to sort of reduce your exposure to that potential array of compounds. But I think it's a very hard measurement to actually interpret.
Yeah, I would follow with that. Is that I totally agree. I mean, you don't really know what the number means. But the relative number, whether it's a small number or a big number, may have some value in communicating the air quality. And I'm speaking from personal experiences. There's a commercial air sensor on the market that you can put indoors, and it has a different color LED that for particles, not for VOCs. And so it lights up with a different color depending on the levels of particulate matter in the air. And I find it very effective. You know, I look at it and I see it's green, and I look at it and I see it's orange, and I know that there's something different in my house. And so I think that maybe those TVOC sensors should only be used in that sort of qualitative manner of sort of low, medium, high, as an indication of just, you know, just that if you're got lots of candles in your house, or you know, essential oils that are getting infused into the house, you know, maybe you'll see higher signals, and that'll tell you that there's stuff in the air.
The report also goes into there's a need for like research to try to understand how human behavior might be impacted by those sensors. And so we don't always know what the person is going to do when they actually see, say, that orange light come on, and do they clearly understand what mitigation strategies like opening a window might have as a benefit or not as a benefit. So there's not just a need for understanding how the sensors work, but also how people work in response to that sensor information.
If I can just quickly add, sorry, Allison, I think Delphine made this point really well, but you know, I don't know that we specifically talk about TVOCs in the commercial sensor, low-cost sensor world, but a lot of measures reported by those sensors sometimes are approximations or calculations based on other sort of more basic types of measurements. So we don't exactly know what that is quantifying. Yes, there could be uses like John and David just mentioned, but we also point to and talk about the importance of kind of standardization and certification programs to really know, you know, get a sense in the hundreds of sensors that are out there on the market, which ones are kind of ranking a little bit higher or lower in terms of their actual performance and what are they measuring. And there are several agencies doing that kind of work that we also point to, not just the EPA, but South Coast Air Quality Management District, etc. So it can get confusing for the consumer for sure, but you know, we do talk about the need to standardize some of this information.
I think we have one more question that came in on the topic of VOCs kind of generally. How effective is technology like activated carbon for removing VOCs, and are there other kind of options that might be effective for that sort of thing?
In general, go ahead.
Go ahead. No, Glenn, you go ahead.
Activated carbon it can be quite effective if you have enough of it. It's, you know, but it lasts a limited period of time. You have to replace it fairly frequently, and you have to make sure the air is actually going through the activated carbon filter. Some activated carbon products don't even have a fan, you know, they just sort of sit there. And so the activated carbon itself has to be somehow in contact with the air, and it can be very effective. So you just have to follow the manufacturer's instructions on that. If that matters to you, is it appropriate to use activated carbon? It's not clear whether that we should be using it, you know, when you can maybe use ventilation, perhaps. Yeah, I don't use activated carbon in my own home. I don't really see any need to. But I don't know, Delphine, what did you
No, I think that's the first point, is that it can be effective, but you have to use enough of it and refresh it often enough, and it's unclear how useful it is. I think one other point to make is that one thing that we've learned over the last few years, and it's definitely in this report, is that a lot of organic compounds, we call them volatile organic compounds, but they don't sit in the gas phase. A lot of them behave semi-volatile, and they'll just sit in reservoirs on surfaces, on your walls, on your floor, on your fabric, and those surfaces, what that means is that there's this huge reservoir of organic material. So if you turn on one of those, a filter with an activated charcoal filter, then you might remove all the VOCs or some fraction of the VOCs that are in the air. But the moment you turn it off, you now have this huge reservoir of compounds that are on surfaces in your building, and they may be able to just come back out and reestablish an equilibrium inside the air in a house. So it's a little unclear yet too whether or not, as Glenn I think it pointed out very nicely, whether or not those are really necessary. Are they doing the thing that we need them to do? But also, how long do you need to run them? I think there's a big question there.
As a follow-up to that, there's other than economic, there's no real disadvantage to activated carbon. It's very safe. It just absorbs things. And, as long as you replace it with some frequency, there is some chemistry that can happen on activated carbon that may not be great, but it's on the whole relatively safe. One really big advantage, I would say, from a societal health perspective, is that activated carbon can remove ozone. And we know ozone is not good for us. Now, whether every home should have some sort of ozone removing system in it is a question I'm not sure I can answer right now, but removing ozone from the air in perhaps commercial buildings or offices could be a public health benefit. And activated carbon is a really good way to remove ozone as long as you replace it with frequency. Bill, do you have a comment on that?
Oh, yeah, I was going to say that I have activated carbon integrated with the Hepa filters I have in my air cleaners at home that I got really to control PM, but we've got pets like many other people, and I find that subjectively the air quality is better, so they can be good for odors, but knowing exactly what a sorbent is doing when you put it in your building is really hard to say, as we mostly know what they do with individual contaminants, and if you've got mixtures, who knows? And as Delphine said, you have to run them all the time, but I do run my filters all the time. So that's something to keep in mind, is that they turn off the air cleaner and everything may come back just as strong as it was before.
Yeah, and I just think, activated carbon, it's been around for a very, very long time. Everybody's just talked about it, but this whole concept of continued chemistry when these chemicals are sticking to the carbon is something that can be further explored. Similarly, Delphine mentioned it, when chemicals get onto surfaces, your windows, all the different surfaces that you can look at in the indoor environment, and how that transforms is something that very few people are looking at. I'd say the world experts are here right now at this webinar to a certain extent, and there are others as well. And I think that just continues to be the question. You have an intent, you have a molecule in the air, you want it to get out of the air. You will buy something and that product will say, we just remove it from the air. But where does it go? And does it have any other continued chemistry is just the questions that have to be asked. And so that's what we put forward in the report, was that we need to get answers to all of these questions.
To follow up on that, Vicki, I totally agree. We agree as a committee, of course, and that using chemistry for control is rife with problems. I mean, it can be rife with problems. And generally speaking, if there is some suggestion that we use chemistry as a control mechanism, it needs to be studied extensively before it gets used in a real consumer product. I think I'm not sure if we actually say that necessarily in the report, but in general, that's the sense I think that we try to put in the report. There are potentially ways to use chemistry in a positive way. Activated carbon adsorption is chemistry. That is a chemical kind of transformation here. But generally speaking, chemistry is difficult to implement in a real environment without having unexpected or unintended consequences.
I think that sums it up quite well. I have one kind of close to the end question. Is there anything that you personally have changed to reduce your own exposure to chemicals in indoor air, or to reduce the potential for chemical transformations indoors, based on what you've learned by working on this report or by working in this field for a number of years?
I can start. I use the back burners on my gas stove instead of the front ones, because I know the air will get ventilated better from those. I mean, I think I follow the directions that are on the labels much more closely. So, it's cold in Canada. I'm from Toronto, so it's cold in the winter. And so when I clean the bathroom, and I want to scour things, I open up the windows, even though it's cold outside, to ventilate well. And so I think just, following the directions and using as few things as necessary, artificial chemicals as necessary is what I do now. And I bought one of those indoor particulate monitors as well.
I'll jump in. Oh, just broadly, I not because of the report necessarily, but over the years, I've stopped doing certain things. Like I don't use any scented products. I've never really liked them to begin with, but I don't use them at all anymore. There's plasticized materials that can go into building materials, which I avoid putting into my home. I actively look for materials that do not have flame retardants in them, like furnishings, that sort of thing. So there's a number of things like that I've changed over the years.
Yeah, I have these Hepa filters. I live in Colorado and we get these wildfire events in the summer. And so I got these Hepa filters to clean the air when those horrible smoke events were happening. And now I just run them all the time. And that's one thing that the last few years of research have definitely emphasized for me.
Well, I've mentioned some of the things that we've done. I think getting rid of sinks like carpets made a big difference in our air quality. Upgraded filters to the extent that we could. Have got the equivalent of MERV 13 in the air handling unit in our house, and we will often run the fan even when there's no cooling load, just to circulate air. I have 7 HEPA activated carbon air cleaners, as they do it room by room, so you don't have to run them all the time, and measure PM and CO2. And also, in a home, containing contaminant sources can create problems. So everyone will have to think about whether they can take this advice or not. But I always make sure the bedroom door is open at night, because a lot of research is coming out on how bad the air quality gets in sleeping environments when you lock yourself in an unventilated home. So some of the things that we've done.
Just one more thing, since I'm open air. I think I'm much more aware of moisture than I was, 10 years ago. Moisture is something we haven't really discussed in this forum, although we discuss it in the report. It can promote a lot of problems, and microbial growth, et cetera, hydrolysis, there's some chemistry that can occur. And so I'm keep a much tighter rein on moisture in the house.
I might go in a slightly different direction. Things that have changed over the time I've spent working in indoor environments is being curious about what has high salience for people in their indoor environments. I find most people that I talk with, if I try to tangentially get to indoor air quality, it's like a dead end. It's just not what people think about when they walk in the door. The way that people think about the weather when they walk out the door. I'm sort of curious, what do people think about when they walk in the door? And so I think what's changed is that I try to ask people questions about their indoor environment that they get excited about, like comfort and pleasantness, and like try to understand what physically is underlying that experience. That's maybe what's changed the most. I'm really curious about that. Like people check their app for the weather when they walk out so they can be prepared. Like what are they paying attention to when they come back home? So, that's not in the report. Don't worry.
I think
Just
Dave
answered
mentioned a
the
couple
personal.
of things that are important, using your fan when you cook. So if ever I start, and John mentioned using his back burners. So whenever I cook, within a second, if I don't have the fan on, I'm like, I need to put the fan on. And so I think that's really important to do. And I'm lucky enough that I live in San Diego, and so we have a lot of windows open all year round at night, and so we use a lot of that ventilation through just opening our windows, and it's been we've been fortunate in not having some of the wildfires, at least here in San Diego, that others have experienced in Colorado and elsewhere. So I think that's important. And, you know, you make a great point, Ellison. I think we've all become resources for our neighbors. And, you know, oftentimes a neighbor will tell me, you know, what would Vicky do if, you know, in this situation? And so I think we do, you know, share our experiences with people around us and hear more broadly in this webinar to really talk about some of the key issues of what you can do, and then some of the things that we feel as experts need to be further explored. And I think a lot of this webinar has been about that too.
Excellent. Thanks for sharing all those thoughts. We're coming up to the end of our time, and so I wanted to open up the floor briefly to see if there are any kind of final remarks that the panel would like to leave with the audience before we close.
So Allison, I'd just like to thank you again and your colleagues at EPA for giving us this opportunity to host, you know, to have this webinar. And also, once again, a nod to EPA for actually sponsoring this Academy's report. I think it was very valuable. And you know, I just would encourage the listeners of the webinar to use this resource. It's freely there for you. And, you know, I think we've discussed a lot of things that people can try to apply in their own home environments. And, you know, again, just thank you for the opportunity. I'd like to thank the other members of the committee for joining me today, and the other members of the committee that were unable to join us today as well.
Thank you. I really appreciate everyone's time and for being here. And it's been a pleasure having you for our IAQ Science webinar series and hearing more about why indoor chemistry matters. And I appreciate all the other activities that you all are doing to raise awareness of the report. And I'll remind everyone from the audience that there is a link in the chat for you to download the report if you haven't already. So be sure to click on that link before you leave. And thanks again for the questions that you've submitted online today. And for future IAQ Science webinar announcements and to learn more about indoor air quality, you can visit epa.gov/IAQ for more information. So thank you, everybody. Enjoy the rest of your day.